Hi everybody, Mr. Rubo here. Today we're on topic 1.5, polynomial functions and complex zeros. So we're going to start off with just defining what a zero of a polynomial function is. So given a polynomial function, if when you substitute in some a value, it's going to give you 0. That means that a is what we call a 0, or also use the word root. If a is a real number, then x equals a is a 0 of p, then x minus a is a linear factor of p. So this is a very important concept when trying to write when trying to write polynomial functions, is if you know some 0, you know how to write it as a factor. So x minus a is how we would write it in the equation. All right, so now you can have a 0 happen more than once, okay? And so this is what we call repeated zeros. This also deals with what is called multiplicity. And let me make sure I spelled that right. Multiplicity. Yeah. So if a linear factor, x minus a, just like we had up above, is repeated n times, the corresponding 0 of the polynomial has a multiplicity of n. So again, that means that x minus a, if you have x minus a times x minus a times x minus a, its multiplicity would be 3 because it's repeated 3 times. Okay. So typically we know that zeros you usually pass through the x-axis. Okay. However, when a 0 has a multiplicity greater than 1, the graph will behave differently than near 0. So what we see here is, and we'll see in this next example because it has good examples of each, based on the multiplicity of each factor, that'll have the x-intercepts behave a little differently. So the multiplicity of a 0 is the degree of just the factor. Okay, so if we look at this example here, we have x plus 4. It happens to the first power, which means its multiplicity is 1. Okay, x plus 1, its 0 would be negative 1, but its power is 3, so it has a multiplicity of 3. And then same thing with this last one, x minus 3 is the factor, so x equals 3 is the 0. It's raised to the second power, so its multiplicity is 2. And if we look at this graph, each one is done a little differently. So at negative 4, the multiplicity of 1, it went straight through, okay, like a linear function would, going straight through the x-intercept. Then the next one that comes in line is this negative 1. So negative 1, 0 is the point. And you'll notice it's not straight through. It goes like a cubic, okay? So it has a little bend to it, squiggle, if you will. Okay, and then the last 0 is that 3. It has a multiplicity of 2, and it does almost like a quadratic shape, and we would call this like a bounce. Okay, so that's what this kind of talks to. So at x equals 3, the multiplicity is 2. The graph of the polynomial is tangent to the x-axis. In other words, the graph bounces off the x-axis. Okay, so the last bit here, the graph of polynomial will always be tangent to the x-axis, or bounce off the x-axis at any 0 with even multiplicity. So we had a multiplicity of 2, it was 4, 6, 8. Any multiplicity that is even, you're going to have that bounce feature. If it's odd, it's going to go through. If it's the first multiplicity, it's going through linearly. If it's higher than that, third power, fifth power, seventh power, 101st power, it's going to go through with that squiggle. All right. Thanks for watching, everybody, and have a good day.